So in this video today, we're going to go over exponential functions of both growth and decay. So an exponential function has the parent function f of x equals a times b to the x power. B always represents growth or decay. The base b is always a constant, and the exponent x is the variable, okay? So what we're going to do is we're going to talk through this. So f of x equal to a times our base b to our exponent x, where b is always going to be greater than 0, and b does not equal 1, because obviously b to any power is, if it's 1 to any power is going to be 1. So in a growth function, the number taken to the x power is b is greater than 1, but when in a decay function, it's going to be between 0 and 1. So our b will be between 0 and 1. So what that means here is that this number is greater than 1 when it's a growth function, but this one is going to be a fraction or a decimal when it's a decay function, okay? So in a growth or decay function, a is also the y-intercept. So that's where the graph crosses the y-intercept, or the y-axis. So in example 1, we're going to do f of x is equal to 2 to the x power. So we're going to build a table of values by graphing the function and using the table function to find the values. So we're going to do this in Desmos. All right. So here we're going to take our 2 to our x power. And notice our graph. It's really close to the x-axis there, and then it gets really tall. So what I want to do with this is I want to go ahead and build a table. And in our original what we had up there, we had -2, -1, 0, 1, 2, and I'm going to put 3 here as well. So these are the values that were already in there for the x values. So what we're going to do is pull the y values by using this table, okay? So let's go ahead and do that. Put those back in here now. So we're going to put 0.25 here. That was 1/4. This is 0.5. This was 1. 2 to the first power was 2, 2 to the second power was 4, 2 to the third power is 8, right? So now we're going to go ahead and plot those points on our graph. We're going to talk about what we see. So at -2, we have 0.25. That's really close to the x-axis. And then we have 1/2 here, 0, 1 there, 1, 2, and then we have 4, 2, 4 there, and then 3, 8 up here, okay? So let's go ahead and see if we can draw this to the best of our ability. So that is what our graph of 2 to the x power looks like. Now notice that as the x values decrease, as we had left on this graph, that the function gets closer and closer to the x-axis. The function never reaches the x-axis because the values of 2 to the x power cannot be 0. So when we approach this line, we call that line an asymptote, because the graph of the function approaches it, and they get the values get really small for f of x, but they never actually get to 0. So in this case, we call the x-axis an asymptote. So if you notice here, we start really low and get really big, right? So this is what we call a growth function, okay? So they're always going to look like this. They're going to start out really close to the x-axis and then get bigger as they move to the right. So the asymptote here is the y-axis, or the x-axis, so that's y equals 0. And the intercept, notice here where our graph intercepted the x-axis, that is 0, 1, right? That's always going to be what an intercept looks like. It's going to start with a value 0, and then it's going to have wherever it crosses. The domain of this function, that's our x values, right? So our x values, you notice there's no end to our x values. So that's going to be what? All real numbers. And then with our range, notice that all the values of our y's are greater than 0, right? So y is going to be greater than 0. So then now let's talk about what are the end behaviors of this graph. So as we head towards infinity here, where is the graph headed? Looks like it's going up and up and up, right? So that's headed towards infinity, but as we head towards negative infinity, where is the graph headed? Yes, it's headed towards 0. Now recall, it's not going to ever touch 0. And remember, f of x means y, but it's going to approach it, okay? So now let's do another one together. So this next one is example 2, 6 times 3/4 to the x power. So once again, we're going to use Desmos to see what this looks like and pull our x values for our table. Okay, so I put this function up here, 6 times 3/4 to the x power. Notice this time it starts out high and gets really low. So just by looking at this, this would be a decay function because it starts big and gets smaller. So once again, let's see what kind of values we can pull to build our table with this time. So notice at -2, it's already at 10.7, and our y-axis on here only goes up to 10. So then at -1, 0. So let's actually just pull some values that we know are on our yeah, let's see. That's 1, 2, 3, 4. How many do we have? 1, 2, 3, 4, 5, 6. 6 spaces, right? So that's 5. So let's put 4 in here, and then let's put 10 in here, okay? So those should be enough values for us to graph. So we're going to pull these and we're going to put them in our table. And I did it by 2's. Actually, I got a -1 there, but I did it mostly by 2's because that's what our table is, okay? So now what I did was I took those values and I put them in our table. Now what we're going to do is go ahead and graph this. So at -2, we were at 10.6. We'll just say it's kind of up there. At -1, we were at 8. At 0, we were at 6. Sorry. At 2, we were at 3.4. So we'll say close to 3.5. At 4, we were 1.9, a little bit below. And then at 10, we were at 0.3. Okay. So again, I'm going to draw this graph to the best of my ability. Okay. So we're going to talk about some things as we look at this graph. So is this a growth or decay graph? I think we already talked about that. This is a decay graph because it starts big and gets smaller and smaller and smaller. Our asymptote is still going to be y is equal to 0 because it approaches the x-axis. This time I want you to notice what our intercept is. You notice it's that 0, 6 right there. And there is a relationship. Notice this 6 up here, okay? That is in front of, that's our A, right? So that's always going to be our intercept. Now, as x approaches -infinity over here, what's happening to f of x, okay? So as we go left, what's happening to this is going towards infinity, right? And as we go towards infinity, it's going to approach 0. And our domain, again, is going to be all real numbers, and our range is going to be y is going to be greater than 0, okay? So some of these are going to be consistent. Our asymptote is going to be always y equals 0. Our end behaviors are going to be infinity or 0, and they may flip-flop depending, they actually do flip-flop depending on whether it's growth or decay. Now, our domain is always going to be all real numbers, and our range is going to be y is going to be greater than 0. Okay, so what I'd like you guys to do now is go ahead and do this next problem. Come back to me when you're done. But before you graph, is there any information from the equation that you can use to make a hypothesis about what the graph's going to look like? So what do you think is, what does this 1.05 mean? Yeah, you should be able to tell now because that's greater than 1 that this is going to be a growth function, and that this 100 is where this function is going to cross the y-axis, right? Okay. So go ahead and do this one. Come back to me when you're done. So once I put this one in Desmos, I zoomed way out. So I just kept scrolling out till I could see about what it looks like for us on that other graph. Now, what I want to do now again is find some points that we can go ahead and plot, okay? So on this graph, I want you to notice that our x values are between -10 and 10, but our y values go up to 200. So let's go ahead back to Desmos and see what we can do here. So now this is kind of perplexing because if we scroll in, we can kind of see that there are some values. See this where -10 is, but they're way up there. Okay, so I'm going to go ahead and put in, let's see what happens when we put in -5. That's 78. Let's go bigger. Let's do -10. Okay. So that's 61. Let's just then go in the middle, -5. And then let's go at 0. And then let's go to 5. Wow, that's up there pretty high too. And then let's go to 10. Okay. So that should give us enough to go ahead and graph, right? The function. So let's go ahead and put these values in. And actually, before we put those in the table, note the shape of this graph. It starts again really close to the x-axis, and it gets really tall really fast, okay? So now I just went ahead and put those 5 values in our graph. So I'm going to go at -10, That's going to be 61. So I'm going to go like, let's see if I can get my pen to work. And at -5, I'm at 78. So that would be close to 80, right? So we're going to say a little bit below there. And then at 0, we're at 100. And then at 5, we were at 127. So we're going to say pretty close to 130. And then at 10, we were at 162. So we're going to go just above 160. Okay. So this is what our graph would look like of this one. Kind of flat on this one, right? But again, remember that it goes up really high, really fast. So this is going to be a growth function again. And it's going to be a growth function because it starts low and it goes really high. Now, if we scroll down, obviously beyond those numbers, it's going to get really close to the x-axis. So once again, this is going to be y is equal to 0. Remember, our intercept is right here. So that's going to be 0, 100. And then as x approaches the left of our graph, negative infinity over here, the graph is going to approach 0, right? Because this is a growth function. And as we go right, it's actually going to approach infinity. So our domain, again, is going to be all real numbers, and our range is going to be y is going to be greater than 0, okay? All right, let's see if you guys can do this next one. Come back to me when you're done. All right, so once again, let's go to Desmos and see if we can click back here. And let me go up here, clear this out. We're going to put in this function that we just did, or that we're doing on this one. So on this one, this is going to be a decay function, 0.075 or 0.75 is the same as 3/4, right? Now that could be any number that is between 0 and 1, right? So once again, this is a decay function. We're going to actually pull some numbers here by clicking up here. And again at -2, let's just see what happens at -3, just to make sure that that's not bigger. Yeah, that was at 8.5. So we could then look at our -2. Then we've got 0, 1, 2. Let's go to 4. And then let's also go to 10 and see what that is, okay? So this one gets pretty small pretty fast, doesn't it? So let's go ahead and which of these values do we want to pull? Let's see. We could just start at the -2 and then do 0 and then go 2 and 4 and 10, right? Okay. So I went ahead and pulled some of those numbers from that table. So at -2, we're at 8.9. So that's pretty close to 9. At 0, we were at 5. At 2, 2.8. At 4, we were at 1.6, and then at 10, we were at 0.3, okay? So here we go again. This is our graph. So is this growth or decay? This is decay because it starts high and gets really close to the x-axis again. Our asymptote is going to be y is equal to 0. Again, this value right here is going to be our intercept, so that's going to be 0, 5. As x approaches negative infinity, we're going towards infinity, and as we go towards positive infinity, it is going to be 0, right? Then our domain, again, all real numbers, and our range is going to be what? Y is going to be greater than 0, okay? So now what I would like to do is go over just these. So we're going to actually dial in on a couple aspects of growth and decay functions. So first of all, we want to look to determine if it's growth or decay at this number, the number that's being taken to the power. So because that's a 5, which is greater than 1, that means this is growth. And then to find our intercept, our y-intercept, it's going to be the value that is in front of that, our a. So this is going to be 0, 2/5. All right, so on the next one, same thing. So this is going to determine whether it's growth or decay. That's a decimal. So this is going to be decay, right? And again, if we're looking at where it's going to intercept the y-axis, this is going to be 0, 7. All right, look at it this one. This is 1/4. So this is another decay function, again, because it's less, it's between 0 and 1. It's a fraction or decimal. And then our intercept, again, is going to be 0, 3. Our last one down here, again, we're looking at this number. That's greater than 1, so this is going to be growth. And then our intercept is going to be 0,500. All right, I'd like you guys to do these last 4 just for practice, and then come back to me when you're done. Okay, here again, this is 3/5, so this is going to be decay because that is a fraction, right? And then this is going to be our y-intercept, so it's going to be 0.30. Here, 0.99, another decay, isn't it? Okay. And that 100 is going to be, or 1,000, sorry, is going to be where it intercepts the y-axis. All right, so this times 60, so that's going to be growth. And where this one intercepts the y-axis is really, really small. And so, yes, it can be really, really small. It's still above 0. Notice that. All right, so our next one, this one could trip some people up, but it's 1.25, so it's still greater than 1, guys. So this is still growth, okay? And where does it intercept the y-axis? At 0,1/4, okay? So hopefully that gave you enough practice to kind of get that down.